Okay, pre-cal students, let's go ahead and start part 2 on your review sheet. Isn't it funny? I'm your math teacher and I cannot even count to 9. I told you guys the first part 1 had 9 problems and the second review part 2 had 9 problems. I miscounted, which is kind of funny. The first part 1 had 10, so this review sheet part 2 will have 8 problems. Okay, so kind of funny on my counting ability. So we got 8 problems. Here we go. Number 9. Let's go ahead and get a picture real quick of what we're looking at here. We do not care if the triangle is drawn to scale. That's not a big deal to us. A, B, C. Angle A is going to be, and I'm going to convert that over to decimals real quick here. 28 divided by 60, it'd be 4.666, so 47. So we're looking at 133.47, and angle C would be 31.7 degrees. If we convert that over to decimals, 31.7, and then side B is 890. Now, here we go. Let's think this through. Step 1 is let's see, is that right? A, C, B, that's correct. Okay, step 1 is to make sure we can solve the triangle. We have to know at least one side, and we do right here, and then 2 other parts, and we do. Step 2, if you can find a third angle quickly, if you know 2 angles, find the third angle quickly. So I'm going to do that real quick. 133.47 plus 31.7 minus 180 would give me 14.83 degrees. So very quickly, I found my third angle. Now step 3 says use law of sines if you can, and look, we can. Look at this. We have a pair that we can use. So with that in mind, very quickly, I'm going to say 890 over the sine of 14.83 equals, and let's find side A first. A, 133.47. Alright, if we cross multiply and divide, we will get A equals 890. This should be sine right here. Sorry guys. 890 sine of 133.47 divided by sine of 14.83. Alright, let me grab my calculator very quickly here and type this in. 890 sine of 133.47 divided by the sine of 14.83. And we will get 2,523. So 2,000, A equals 2,524 if we round. Okay, so there we go. And now let's go ahead and let's move on. Let's find the side C, side C. Now actually I shouldn't have erased all of that because we're going to use the same pair. So let's leave that pair up. There we go. And now let's go ahead and find, now I know step 4 says once you've done steps 1 through 3, use the law of cosines. I get that. In fact, let's go ahead and use the law of cosines. But whenever you're dealing with a side, you're pretty safe to use the law of sines. But let's go ahead and use the law of cosines. So the last thing we're looking for is side C. So if we're looking for side C, we put it right there. And then next would be a squared plus b squared minus 2ab cosine, and then of course if you have C over here, then it's C over here. So really we're just going to quickly make some substitutions and type it into our calculator. So A would be 2,524 squared plus 890 squared minus 2,524 890 cosine of, and I should not have put C there. I should have put 31.7. So 31.7 degrees. Okay, let's type this whole thing into our calculator very quickly. So C squared equals, and here we go, 2524 squared plus 890 squared minus 2 times 2524 times 890 times cosine of 31.7. enter. I'm getting a really large number, which does make sense, and it would be 3,340,219.912. Now let's take the square root of both sides, and if we do that correctly, we're going to get C equals, and I'm rounding to the nearest whole number, 1,827.6, so 828. So that would be the length right here, 1,828. That would be the length of side C. All right, so there we go. Let's go ahead and move on to number 10. I hope you're getting this. All right, here we go. Let's draw our triangle, and wow, that's a nice triangle. Let's try that again. Here we go. And here's A, B, C. Now B is 37 degrees. Side B is 4, side C is 8. Now notice what we have here. We have side, side, angle, side, side, angle. That's one of those situations where we might have two solutions, one solution, or no solution, okay? So here we go. Step one is to make sure that we can actually solve this. So we have to know at least one side, and we do, and two other parts, and we do. Next step says if you know two angles, quickly find the third angle. We don't. And then step 3 says you use law of sines if possible, and we can definitely use law of sines because we have a pair. So 4 over sine of 37 equals, and then of course we have a length here, so let's look for this angle right here. So 8 over sine of C. Now if I cross multiply and divide, I'll be left with sine of C equals 8 sine 37 all over 4. Okay, now very quickly, if I type that in my calculator, 8 sine of 37 divided by 4, I'm going to get this right here. Sine of C equals 1.2036. Now we're looking for an angle, so if you then hit second sign of that decimal, you're going to get no solution, no answer. So there is no triangle that exists, students. There is no triangle that exists in which you can have these measurements here. It's impossible. Okay? All right, moving on to number 11. Now we're going to do some word problems. Let's see, about 4 or 5 of those and we'll be finished, okay? All right, number 11. Let me look at my notes here I have written down. Okay, number 11 reads as follows. Find the area of triangle ABC if B equals 9.8, C equals 7.3, and angle A equals 67.3. I would recommend the first thing that we should do here is probably get us a picture of the triangle we're dealing with, like we always try to do. And so I'm going to call this triangle ABC. And we don't have to use ABC, just in this problem that's the letters they use. So side B is 9.8, side C is 7.3, and angle A is 67.3. Now remember, here's what I told you. I told you whenever you have side, angle, side, you can find the area of a triangle without using the old formula you learned in elementary school or middle school, 1/2 base times height. Okay, that's the old area formula for a triangle, and it's fine, it works fine, but you can also use another formula in which we called it this. We said, I really didn't give you this formula, and I know that, so don't worry about it. I'm just trying to show you what the formula would look like if we did. But basically what I taught you to do is simply this. I just said take 1/2 times both sides, so 7.3, and then 9.8, and then times the sine of that included angle, or the angle between the two sides, like this. So what I taught you to do is anytime you have side, angle, side, you can find the area of the triangle by simply putting 1/2 times one side times the sine of 67.3. So let me very quickly grab my calculator. If I type all of this in, and notice all of your measurements were in meters, meters. If you type all this in, you're going to get out approximately 33 and its area, so we're going to say meters squared. 33 meters squared. So there's the area of that triangle. Okay, let's take a look now at number 12. Okay, number 12 reads, a parallelogram has sides of lengths 3.21 and 7.85. One of its angles is 147 degrees. Find the area. Okay, first thing we should do is get a picture of a parallelogram. Now, hopefully you remember what a parallelogram looks like from geometry. Matthew, I know you've not had geometry yet, but that's okay. Let's go ahead and put some measurements down. One side is 3.21, that's what the problem says, and another side is 7.85, so we'll label the longer side 7.85, and they say one of the angles is 147 degrees, so we'll put the bigger angle here as 147 degrees. Now they want us to find the area of the parallelogram. The formula for area of a parallelogram is base times height. So we know what the base is. Here it is. We know the base is 7.85. That's easy. What we don't know is the height. Now, if you're thinking this is the height right here, 3.21, that's incorrect. A height has to go straight up and down like this. Okay? That's the height. And that's what we have to find, is that dotted line. Well, when I draw that dotted line, notice I have a nice little right triangle over here. Okay? And if this side right here is 3.21, then that means this side over here is also 3.21 in a parallelogram. Now again, if you've not had geometry, you might not know that, but now you do, okay? Something else you probably didn't know if you've not had geometry is anytime you have a parallelogram, consecutive angles, that means two angles that are side by side, always add up to 180 degrees. Always, okay? Now that's a big help because here's an angle, and then right next to it's this angle over here. Just forget this height here for a second. Pretend that's not there. Here's two consecutive angles. And so if I have two consecutive angles, they have to add up to 180. So 147 plus 33 degrees is 180. So to find this dotted line, look, let's pull it down here. I have a right triangle. There's my right triangle. And this is 33 degrees, and this is 3.21, and I'm looking for this height. We'll call it x. Guys, let me say it again. It's a right triangle. We can use sine, cosine, or tangent. This is old school. This goes back to like 2 months ago. Okay, based on this angle, this side over here is called my what side? Opposite. This side here is across from the right angle. This is my hypotenuse. So if I'm dealing with opposite and hypotenuse, then I can use sine. I can say sine of 33 degrees equals opposite over hypotenuse. And now multiply both sides by 3.21. So 3.21 sine of 33 degrees equals x. And now let's type this whole thing into our calculators. Let's see what we get. 3.21 sine of 33 gives me 1.748. I'm going to put 1.75. So my opposite side, x, is 1.75. So that means my height is 1.75. So how do you find the area of a parallelogram? Parallelogram, base times height. So my base is 7.85, my height is 1.75. Let's go ahead and multiply those two numbers together. And by the way, we're dealing with feet, so my answer will be square feet because I'm dealing with area. 7.85 times 1.75 gives me an answer of 13.74. Now the book has 13.72, which is close enough. That's fine. We probably rounded somewhere where they did not. And there's the answer. All right, let's take a look now at number 13. A child care center has a triangular shaped sandbox. Two of the three sides measure 15 and 12.5 feet and form an included angle of 42 degrees. Determine the amount of sand that is needed to fill the determine the amount of sand needed to fill the box, the director must determine the area of the floor box. Find the area of the floor of the box to the nearest square foot. So we're going to find the area of a triangle that has the following characteristics. Are you ready? It's going to be really easy to do. So here's A, B, and C. And what they said is we have two sides that measure 15 feet. So here's one side, 15 feet, and the other side is 12.5 feet. Okay, there we go. And then it says this. Listen to this very carefully. It says two of the three sides measure 15, 12.5, and form an included angle of 42 degrees. Now, when it says an included angle, that means it's in between the two sides. So look what I have. I have side, angle, side. So I know how to find the area of this very easily. Remember, it's 1/2 times one of your sides times another one of your sides, excuse me, times the sine of 42 degrees. So with my calculator very quickly, I'm going to type this in. 0.5 times 15 times 12.5 times sine of 42, and I'm getting out 62.7, and I'm going to go ahead and round that to 63. So the answer would be 63 square feet, because we are dealing with area. Okay, pretty easy. All right, number 14. A triangular shaped flower garden has lengths of 11, 9, and 6. Find the angles of the garden. Now this is going to be more of a pain, and so we'll have to work pretty hard on this problem. Okay, here we go. A, B, and C, and the sides are 11, 9, and 6. Really doesn't matter where you put them. 11, 9, and 6. So, are you ready? Step 1, can we solve this triangle? We have to know one side plus two other parts. So yes, we have that. Step 2, if you know two angles, find the third one. We don't. Step 3, use law of sines if you can. Well, we don't have a pair. We don't have a pair, and we don't have a pair. So we cannot use the law of sines. So we're going to have to use the law of cosines, unfortunately. So let's go ahead and start off by looking for angle A. So cosine of A. So I come way over here and I put A squared. Well, that's 81. Then I would put B squared. Well, that's 36. And then C squared, that's 121. And then minus 2BC. Okay? Now let's see if we can do 2BC quickly in our head. 2BC would be 2 times B times C. So 222, I'm getting 132. I hope that's right. And I will check that in just a second, okay? So 2 times B times C, 12, yes, 132 is correct. So there we go. And now notice this is all one term. It must stay together, but I can definitely bring 36 over and make it negative, bring the 121 over and make it negative, and that would give me, if I do this correctly, that would give me negative 76. So negative 76 equals negative 132 cosine of A. And now let's divide both sides by negative 132. Negative divided by a negative is positive, and you get 0.57575757. So 0.5758 equals cosine of A. And then, of course, to find a missing angle, it's second cosine of that number, and we get 54.8. So I'm going to go ahead and put 59 degrees. And now let's just find one more, and the third angle will be very easy. Let's find cosine of B very quickly. So cosine of B, so over here I would have B squared, that's 36, and then A squared, that's 81, and then C squared is 121, and then it'd be minus, what would that be? 2, if B's over here, it'd be 2AC. So 2AC, that would be 22. I'm getting 198. Let's make sure that's right. 2 times 9 times 11 is 198. So 198. Now, let me erase this right here. Now this is all one term, so it must stay together. I can bring 81 over and make it negative, and bring 212 over and make it negative. And I'm doing that right now, and if we do that correctly, we will get negative 257. So negative 257 equals negative 198 cosine of B. Divide both sides by negative 198. And of course it'll be positive because the negative divided by negative is positive. I'm getting 1.2979, so 1.7, so 0.2980 equals cosine of b. Now, we're looking for an angle, so second cosine of that decimal number. And let's see what we get here. We are going to get, and let's see where I messed up here. I know that's not correct. All right, let's see. Okay, students, I apologize, and it's always humbling. I guess I'm a little dyslexic here. Dyslexic. 11 times 11 would be 121, not 212. So there, I found my mistake, and I apologize for that. So we bring the 81 over and make it negative, bring the 121 over and make it negative, and we get, that's more like it, we get negative 166. So right here, we would have negative 166, and then if we take negative 166 and divide it by negative 198, let's see if Mr. Earhart can get this right here. There we go. Alright, negative divided by negative is positive, and if you typed it in correctly you get 0.8383, and that makes a little more sense. So 0.8383 equals cosine of b, and now we hit second cosine of that decimal, and we're going to get 33 degrees. Okay, so b is 33, and now very easily we can find this last angle. 2 carry 1, we get 92, so that would be, I believe, 88 degrees if I did that correctly. Okay, so there are your three angles for that triangle, and of course the third angle was found by simply adding these two angles together right here and then subtracting from 180. Okay, two more problems left. We're done with the whole review sheet, so we're moving along pretty good. All right, number 15. In an isosceles triangle, the base angles each measure 52.3, and the base is 513 feet long. Find the lengths of the other two sides to the nearest foot. Okay, well, let's go ahead and be a little more specific in our drawing this time, because it does say an isosceles triangle, and that means we have two sides that are congruent. So this side is congruent to this side, and it tells us that the base angles are 52.3, so 52.3 and 52.3, and then it tells us the base itself has a length of 513. So this really is pretty simple. We have angle, side, angle, and we want to find the lengths of these two sides right here. Now understand that there's really, you can use law of sines and law of cosines, but students, there's really no need to do that when you don't have to. Okay, learn to think outside the box. That's very good. Because we have an isosceles triangle, that means, now usually just because you drop a line right down the middle of the triangle doesn't mean that it divides this side in half right over here. But when it's an isosceles triangle like this, and this side here is congruent to this side here, which, by the way, that's what an isosceles triangle is. It's a triangle in which two sides are congruent. You can drop a line down, and what it does is it cuts this in half. So 513 divided in half would be, let me get out my eraser real quick, and I know it's going to be a decimal, but this is going to be much easier than using law of sines or law of cosine. It would be 25, let's see, 6.5. So from here to here is 256.5, and from here to here is 256.5. Now you might say, Mr. Earhart, why did you do that? Well, because now I have right triangles. And guys, look, I'm going to draw my right triangle over here. Think how easy this is. Here's my right triangle. I know this length here is 256.5. And by the way, I don't trust my math in my head. I better check that. 513 divided by 2 is 256.5. So I know this length is 256.5. I know this is 52.3. And I know the book is asking me to find these two sides. I'm going to call them both x because they're both the same. Look how easy this is. So here's my known angle. Here's my known angle. What is this side called? Adjacent. What is this side called? hypotenuse. What trig function has adjacent and hypotenuse? Cosine. So the cosine of 52.3 equals adjacent over my hypotenuse. Now multiply both sides by x, so I'm left with x cosine 52.3 equals 256.5. And then because I want to get x by itself, I'm going to come over here. We're going to divide both sides by cosine, so I'm left with 256.5 divided by the cosine of 52.3. Let me grab my calculator very quickly. 256.5 divided by cosine of 52.3, and I'm going to get 419, a length of 419.4. We're just going to say 419. So there we go. This length right here is 419, and this length right here is 419. Now when you dropped this height, this perpendicular line down, you cannot always assume in every triangle that this dotted line is going to cut this bottom length in half, but you can make that assumption when it's an isosceles triangle. And we did have one. Boy, that's a lot easier than law of sines or law of cosine. And now the last problem, it's going to be a doozy. I'm pretty sure I've not worked it out yet, but let's see what happens. Two airplanes leave an airport at the same time. The first one has a direction of 305.6. So I'm going to use two different colors, and I'm going to go ahead and say airplane number 1 will be in red and airplane number 2 will be in blue. Okay, airplane number 1 has degrees of 305.6. So watch this carefully. I go 90, 180, 270, and then I would have to go 35.6 more degrees. So there we go. And then here's my airplane right here taking off. Okay. And there it is. Okay. Now, listen, let's go ahead and do one more thing while we're dealing with the red airplane. We know, if you look at the very last sentence in the problem, it says after 2 hours, how far apart are the airplanes? So the first airplane is traveling 175 kilometers per hour. It does that for 2 hours, and so you're going to get 350. All right. So the distance this airplane has traveled is 350. All right. Now I'm going to go ahead and switch over to blue ink, and let's see if we can get a picture of the blue airplane. Okay. Blue says it's flying in a direction of 195.5. So here's 90, 180, and then I want 195.5. So that's going to be 15.5 degrees, so just a little bit, and I'll stop right there. And here comes the blue airplane taking off, and it's traveled for 2 hours also, and it's traveling at a speed of 220 kilometers per hour. So 220 times 2 would be 440. So there we go. There is there's the distance of that airplane. So the question is how far apart are the two airplanes? So if I'm able to, I'm going to go ahead and connect these two dots like that, and we can fix that in a second. So the green line is what I'm looking for. And that green line is the distance between the two airplanes. So basically what I have is a triangle. Now, can you please do some math with me? Watch this carefully. Remember the red line, students? I went 90, 180, 270, okay, and then I went 35.6 degrees more. So this angle right here, from here to here, that angle right there from the red line here to the black line is 35.6. Now, can I find the angle from the blue line to the black line right here? I hope so. Let's see if we can. The blue airplane went 90, 180, and then it went 15.5 more. So from this black line here to this blue line here, I have a measurement of 15.5. Okay, Now this whole angle here is 90. That whole angle right there is 90. So if from here to here is 15.5, then this would have to be from the blue line right here to the black line. That angle would have to be 64.5, because 64.5 plus 15.5, actually I'm wrong and I apologize, that'd be 74.5. So from the blue line here to the black line there is 74.5, because 74.5 plus 15.5 gives us 90 degrees. So please watch what I do next. What is the measurement of the angle from the black line to the red line? 35.6. What's the measurement here from the black line to the blue line? 74.5. So what's the measurement of this whole angle and this triangle? Well, if I add those two together, I will get that answer. So what I'm going to do now is I'm going to take my pen in black. I'm going to trace over this triangle. And that's the triangle I'm going to use. There it is. And now I'm going to pull that off to the side and erase everything else. So now I've done all that work to find this triangle. Do you see that okay? And now I know the angle right here for this angle right here is going to be, let's see, 1 carrier 1, 0 carrier 1. I'm getting 110.1. So if you add these two numbers together, let me check it again. You get 1 carrier 1, 0 carrier 1. Yes, you get 110.1. So, and then also I know this length here is 350, and I know this length right here is 404. Now you might need to back this up and watch this a couple times, okay? I don't know. That's up to you. But that is how you would do this problem, okay? Let's see if I can get rid of this black line a little bit. There we go. And I think we're doing pretty good. Okay, so what I'm looking for is the length between the two airplanes. I'll call this x, and we can use law of cosines. I can definitely say x squared equals, as long as way over here I take the cosine of that opposite angle, which is 110 degrees, 101.1 degrees. So here we go. X squared equals 350 squared plus 440 squared minus 2 times 350 times 440 times cosine of 110. So x squared equals, let me grab my calculator real quick here, and 350 squared plus 440 squared minus 2 times 350 times 440 times cosine of 110.1. I'm getting a large number of 421,947.1859. And then I hit second square root of the answer, and that gives me this right here. I took the square root of both sides, and that gives me 649.5. So I'm just going to say 650. Now remember, all my measurements were in kilometers, so the answer is, how far away are the airplanes from here to here? 650 kilometers, okay, which is correct. Okay, that's the entire review sheet. I hope this has been a help to you. Email me or call me if you have any questions.